for the supermarket shelf management, specifically the market-based model, so the goal is to find items that are bought together by sufficiently large number of customers. So you would like to process the sales or the data collected with barcodes to find like dependencies among the items or co-occurrences. So look at this rule. This is like what they learned after applying like association rule or association analysis. Look at what they learned. Suppose if someone buys diapers, then he or she is likely to buy beer. Suppose it is non-alcoholic. So do not be surprised if you find 6 packs of this beer next to diapers. You see the point? So they would like to let people buy as much as possible so to increase the profits for the supermarket. As an example, I see like 3. We are waiting. Okay, we will be waiting. So almost we have 2 left. So we will be waiting. For the lab, let me know if you have like any question yesterday. If when you applied, did you have like some issues or you ran, everything was fine? Have you installed R into your own like local machine or you had like problems? Good. Yeah, inshallah. Next class we will try to use like some programming. So we will call like R packages. So highly recommending like to have it in your machine so you use it inshallah. Okay. So our talk is about association analysis. We would like to find like the dependencies between like items or whatever. It depends on the context. So for a supermarket example, you would like to find like those items bought together by many customers. So you would like to attract people coming to your like your own business so to benefit. So you would like you have like data stored in your like machine. Once you process these barcodes, like once you buy or purchase, you have items that you bought. So they would like to learn something. So suppose they did association analysis. Suppose once they apply association analysis on data collected from customers, so they could learn a rule like this one. Suppose this is the rule. If someone buys diaper and milk, then he or she is likely to buy beer, non-alcoholic. So what do they do for the business? Once they learn this one from association analysis, like they know the dependencies between the items, they place these 6 packs of beer next to diapers. You see the point? So they would like to attract you. They know that you are most likely going to buy beer. So I think you have seen this one, like when you go to any supermarkets here, you find something like this. Am I right? So once you go there, try to pay attention. So for applications, suppose items are products, and then you have baskets. So sets of products someone bought in one trip to the store. Okay. So for the real market, baskets, chain stores keep terabytes of data about what customers buy together. Okay. So why this one is important? So tells for them as a business, tells how typical customers navigate stores, let them position or placing tempting items together. So as an example, used to position potato chips between diapers and beer to enhance sales of potato chips. So they like just to buy more and more. That is the goal. So to increase their profits. Amazon as well. People who bought X also bought Y. You see this one on Amazon. Like people who bought like this book also bought that one. I think you see it. Am I right? If you go to the website, you see it. Good. Yeah, so they try to be like clever about increasing their sales, and this what at the end they would like to sell as much as they could. Okay, so for this application, suppose baskets are sentences. So I have sentence. Okay, good point. Yeah, because this happens. Yeah, it is not like 100%. Also, that data depend on the citizens of that country. American, you know my point. So me or someone from Saudi Arabia going there trying purchase, it will not affect because you have millions of transactions, and you have the majority will be like following the pattern of American citizens. You know my point. But for us, if we have Amazon's ours here, we try to purchase. So the software will try to find associated items related to our own flavor. So this is like the issue point that you mentioned. So for items, suppose you have documents in which those sentences appear. So look at this one. When they apply association rule, items that appear together or sentences that appear together too often could represent plagiarism. It makes sense. Am I right? Yeah, so in other words, this application, why it is called application? Because they do problem formulation. Oh yes, yeah, that is, yeah. If you would like to argue with this, yeah, you are right. It is like, but I'm saying just like in terms of the country, this is what I meant. Like confirming what you are saying, there are many factors. So the data there have like the different like features or something in terms of like um, the customers. I'm not sure if they use like other information from like the cookies or whatever. We do not know. So they might combine from different data sources. You see my point? It might be this one or others as well. This is like the secret of recipe of Amazon. So for us, we do not know. So for this one, suppose for baskets are patients, items are what? drugs and side effects has been used to detect combinations of drugs that result in particular side effects. So once you do problem formulation, you might use association rule to help you solve one of the problems. Okay, we go next. Let me go back. Okay, so suppose you have like basket, you have like basket here. You have sentence, sentence, sentence. This is like in terms of like their own representation. So if you have sentence, 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 and you have documents in which those sentences appear, they do it like this way. So they would like to find association. You see my point? Why documents are items? It makes sense. Do you know why? Because they would like to find uh, like close like documents. So they say this guy, that guy. You know my point? Easier for them. So items, according to this context, is like documents. So you find this or that document. So if there is a like a strong association, you could say, oh, that is person A, that is person B. You know my point? So you catch. Easier for you. Am I right? It makes sense. So the representation is important. You see, I like your own way of like uh, swapping the roles, but now we see like what once you do. So for them, I am so sure once you tackle a problem, they did your own proposal, but then they swapped it. You see the point? So they made it like easier for them. Once if it's a problem, you try to solve it. So you have like a loop. So now, what is association analysis? Association analysis uses a set of transactions to discover rules that indicate the likely occurrence of an item based on the occurrence of other items in the transaction. Okay, so look at this one, for example. This one is rule, okay? Rule, rule. So we have 5 transactions. Transaction 1, bread, milk. 2, bread, diaper. Beer, eggs. I would like to mention something. I update the slides. I would like to make sure that it is like as concise as possible. I don't want to include additional things that might confuse, because I would like the topics to like flow together. So like when I give like arithmetic operations, I would like them like addition, multiplication, subtraction. I don't want to have like so algorithm. You know my point? I don't want to make them like too far. I would like them to have like harmony. Okay, so implication here, pay attention to this one. Means what? Co-occurrence, not causality. Okay? So if you buy diapers, you are likely to buy beer. You know my point? It is about co-occurrence. So you would like to find the association between the items. So what is item set? A collection of one or more items. Look at this example. Okay? looks like in mind a set of one or more elements. You see my point? So item set. K item set, it is an item set with what? K items. So this one is what? 3-item set. Am I right? And so on. Yeah, try to grasp the concepts. So this one, you have, remember that one. Collection of one or more items. K item set referring to what? 3-item set for this one, for example. Okay, now we go here. Now support count. Pay attention to this one. This one is different from that, okay? So support count. Frequency of occurrence of an item. So look at this one. What is the frequency of this item set consisting of these items? So once I apply the support count, I'm looking at the frequency of these items here. So now we will do, I will magnify the slides. Okay. Look here. We would like to find together these in each transaction. So if it is there, we say 1 and so on. So now you are saying 4 to 5. We could have one answer, not two. Okay, so, oh, I see your point. You mean 4 and 5? Yeah, okay, I see. Yeah, you are saying that appears in transaction ID 4 and 5. Well, yes, good. So how many do we have? We have 2. Yes, you count. If it appears here, 1. If it appears there, you add 2, and so on. Milk, bread, diaper, yes, here, here. Do we find it here? No, that's it. Support, a fraction of transactions that contains an item set. Okay, so now for support, there is a difference between support count and support. Okay, so S, that one is like sigma. Okay, so the support for this item set is what? Look here, we would like to count. So it is just counting support count divided by what? The total number of transactions. Do you agree? So you count. Good. Okay, so yeah, this one is like, okay, now it's good. So for this one, you count. It is like support count divided by what? The total number of transactions. I have 5 transactions here, and here I have support count. Okay. Frequent item set, an item set whose support is greater than or equal to minimum support threshold. So this is like a user defined. You specify this one. So an item set is frequent if it is greater than or equal to a minimum support threshold. So if an item set satisfies this one, you say this is like a frequent item set. Okay. You could say, you ask, is it greater than or equal to 0.2, 0.4, as you like. Okay. If yes, so you say this item set is a frequent item set. So we know if you have an implication like this one, on the left hand side is non-empty, and on the right hand side is not empty. Okay, keep it in mind. So this implication is an association rule. So look at this rule as well. Milk diaper implies what? Beer. Okay. So if you know that these are together, you try to do your own business. You see my point? So you try like to have like beers beside these, or you might do other things. You see the point? Just like you would like to let people come to your own business. That's it. Is there any question? Let me. Okay. Good. So we had like some concepts about support, count. Do you agree? So just to do like some calculations. But now we would like to evaluate these association rules. So for now, for this moment, there are many others. But for now, for this class, we will talk about two: support and confidence. So if you have an association rule, if you would like to find the support, it is calculated as follows: the fraction of transactions containing both. So you combine the items in both item sets, okay? Then you apply the support as before, okay? What about the confidence? It measures how often items in Y appears in transaction that contain X. We will have an example. Okay, so suppose you have this rule, okay? I would like to find the support. Here is what I do. I combine all items. Then I apply what? Support. What is the support of this one? Meaning what? Sorry, this is what? Support count. What is the support count for this one? Just like frequency. How many times it appears in the transactions? That's it. So you said this one and that one. Yes, good. 2. So here is 2. Divided by what? Total number of transactions, 5. Now, what is the confidence? It is what? The support of all items on the right and left hand side divided by what? The support of items on the left hand side. Okay, so here is the meaning. So how often these items appear in the transaction that contain milk and diaper? Okay, so here is what we do. Now for this one we know this one is what? 2 divided by 5. Am I right? What about this one? Milk diaper. So for this one we have what? Let me erase. This one is 2 divided by 5. Am I right? What about this one? Is what? This one is what? Yes, good. 3 divided by what? How many transactions? It is the same as this one. So 2 divided by 5 multiplying 5 divided by 3. This goes with that one. So you have 2 divided by what? Is this point clear? Okay, repeat. So this measure is just to know how many like, or how often these appear into milk and diaper? So you have X implying Y. To calculate this one, I do the following. I do the support for all divided by what? Support for items of X. Okay, here is what we have. Joint, you join, you divide by what? The left hand side, which is this one. I'm taking the support. So this tells me what? 2/3 of those who like of those transactions consisting of milk and diapers also consisting of what? Milk, diapers, and beer. So 67. This one is what? 67, almost like percent. So you would like now to think, oh, this might be good for you. If you have like high confidence, this makes sure that people will take this. In other words, they will take beer. You see my point? The higher the number, the better. You see my point? So you would like this one to be 1, meaning what? Everyone who because we are talking about transactions, not people. Every transaction that has these also has this one. So you know there is an association between beer and milk and the diaper. Is it clear? So once you know these are strongly associated and the confidence tells you like it is 1, you know for sure that what? You could play with the beer. You could like do other things. You know my point? So you could like say, uh, like what they said, what they did, they put beer beside, because if it is 100% confidence, I could put beer beside milk and diaper to remind people, because I know they are 100% going to buy it. You see the point? If it is like this one, I might do the following. It depends on you as a business. I might say, okay, I make 50% discount, 40%. You see the point? 40% discount. You got the point? It depends on the business, like, but if it is like one, this one is 1, I just put beer here beside milk and diaper. That's it. I know you are going to buy it. I will not make any discount. You got the point? So for support, I'm looking for the fraction. What is the fraction or the fraction of these combined from these transactions? So you know this appears here, here, 2 divided by 5. Clear? Now for confidence, I would like to know, like, I would like to know, like, for example, like this one, 67% of transactions of these transactions of milk and diaper also the same for beer. So in other words, beer, you will find like 67 occurring here, or it happens here. Okay, if it is 1, so it is with it, always with this one. So it is like I would like to find the occurrences for beer with these milk and diaper. If you have any like problem, let me know. If others have like problems, let me know as well. Okay, what is the question? Oh yeah, ask. You will come back. Oh, so for the lab, yeah, this one. Oh, they. I'm not sure because it depends. Is it online or like? Oh, I see your point. I see. I see. I see your point. Yeah, I understand. I understand. You have to talk to him honestly. Yeah. Take care, and this is like the class. You could run the cell phone on you. You could run on your cell phone the blackboard. So yeah, I understand that for medical like sciences or uh, like and sciences as in general like biology. These are chemistry. Yeah, so try to be with us. Yeah, like we are communicating over like distance. I think it will not be an issue for you. Like if you, but be careful when you drive. Yeah, that is like another issue. So, oh, I see. Try to communicate with the lab person. So you explain to him about this issue. Yeah, because it is hard, like to do this. Yeah, this is like a tough situation. So highly recommending like to discuss with him. Oh, okay. See. But this class is important, so I don't want you to jeopardize. Like you go. I highly recommend you to discuss with him. Also, if you want me to discuss with him, also we could as well. So, but for you, try first. You ask him that we have a class. So yeah, to make him understand the situation. You are from like Mecca, like this. So or to change like the lab time. Yeah, because this is an issue and it should be solved. The class is like having more hours than the lab. I think so. So if we consider it as important, this class is more important because it has like more credits than the lab. So I don't want you like to skip this class. Or other way, if you find it hard, we could change the timing for our class, not him. Let me know. Yeah, I don't want you to get absent. Yeah, I could make it easier for you. So okay, let me know. Yeah, then if you want to change the timing because I see like two of you, because we have like 14, we could do it easily. Okay. Okay. So now we go back to support and confidence. So the rule that has like very low support might occur like simply by chance. No one is interested like random guess or something. No one is interested in this rule. A low support rule is unlikely to be interesting because it might not be profitable to promote items that customers rarely buy together. So for confidence, it measures the reliability of the inference made by the rule. Yeah, I would like to make sure that it is like high confidence. So I make sure that you are going like to buy it, inshallah. So for a given rule like this one, The higher the confidence, the more likely it is for Y to be present in transactions that contain X, as what we said. Am I right? So you would like the high confidence as high as much. Okay. If it is like 100%, this means you are, this one appears in all transactions. So you could organize items, you make them together, and so on. If it is like 80%, it depends on the business. So you could say, I make a discount coupon or something. You see the point? So you would like him to buy. So look at this exercise. Compute the support for item sets. How many item sets do we have here? Please let me know. From the name, you know, once you have this one, remember the set if you studied discrete math. But actually, just they try to formalize. Otherwise, yeah, why they formalize? Because they would like to write algorithms. But this one is like, we have sets, not like item sets. This is like customized. So how many item sets do we have? Could someone tell me? Good. Tamam. 1, 2, 3. Good. One item set, two item set, three item set. Do you agree? This is the other way to like is good. So now look at this one. I have transactions and item bought, or I have market basket according to what? Customer ID. So we will talk about this. It depends on your business model as well. So we go back here by treating each, I would like to underline this one, compute support for these three item sets by treating each transaction ID as a basket market. So I'm looking into this column. I ignore that, okay? So how many different transactions do I have? I think it is 10. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, good. Good. So these are different. I have to make sure they are different. If not, if two are identical, I combine, and I combine the corresponding items there in one set. You see the point? Yeah, keep it in mind. Oh, so let me. What is the support for this one? For A. Support of A meaning what? I count this one: 1, 2, 3, 4, 5, 6, 7. Yes, good. 7 divided by what? Yes, good. Yes, good. So almost like 70%. What is the support for BD? BD, BD. Do we have something else? Yes, good. 2 divided by the total number of transactions. Look at the notation. Support of A. Support BD. Yes. So 2 divided. Yes, good. What is the support for ABD? So I look for the together. I have to find these together appearing in a given transaction. Then I count. BD. Oh, sorry. This one is what? We are on the next, yeah, ABD. So what is ABD? ABD. Do you agree? 1 divided by 10. Now this is like the 0012 is different. Oh, I see. It appears here only. Okay. So the answer is what? It appears, I count 1 divided by what? By 10. Look here, we would like to keep observation. The more you add, like the more you would like to find the support for more items, the support goes down. Do you agree? You see the observation? So if you start with like, suppose A is like frequent like this one. If you add to A, it goes down. Look at this one. Where is this one? A was 0.7. Once we added BD, it went down. You see? Yeah, pay attention to this. So now, okay. So use the results in the previous problem to compute what? Now we are computing what? Confidence for the association rules. Okay, now we are doing with this one. We used to calculate the support for what? For those item sets. Now we do it for what? We do the confidence for association rules. How many association rules do we have? Good. Okay. So now for the confidence for this rule, the first rule. So the confidence for this rule is what? The support for all these combined divided by what? Support of these combined. So one saying, good, you got it. MashaAllah, tamam. So this one is what? What does it mean? Look at this one. 50%, 50% of transactions containing BD also contain what? A. You got the point? Like half of these contain A. It is simple as this. Am I right? So this is what does it mean by 1 divided by 2. Yes. For this one, we combined. Look, for the support, we do not care about the arrow. We just combined items in both sides. So just combine. Find the support, the frequency, divided by the total number of transactions. So here is 1 divided by 10, and that one is 2 divided by 10. So it is like half. This number meaning what? Half of BD contain what? A. So if the answer was 1, meaning 100%, that means what? A in every BD. They are associating to every time. Is it clear? Yeah, always. Good point. Yes. So this is like likelihood, probability. Good. So always, if it is 1. Okay, now what is the the confidence for this one? A implying BD. Okay, so we see. Yes, good. So 1 divided by 7 of those transactions containing A also containing what? BD. This is not good. Am I right? This is like BD appears in like one times these transactions, like 1 divided by 7 of these transactions. It is like 2. This number is like not good. Am I right? So this rule is like saying you are not sure if they are going to buy it. You see the point? So because this doesn't, it might be a problem in the product, it might be something like reputation, you know my point. So there is an issue. So also for you as a business, you could track these. You could say, oh, this will be expiring. If it is like edible something, you could say, no, next time as a business I will not bring it, I will change my business. You get the point? So okay, hopefully it's clear. Good. Yeah, so this makes your business like in a good shape. Now compute the support for ABD A, one, this is the item set, one item set, two item set, which is BD, three item set, which is what? ABD. By treating each customer ID as a basket market. Look now, how many different customers do we have? Good, yes. So now, before we do anything, we have to do what? We have to combine. So one becomes what? A, B, C, D, E. Am I right? This one, A, B, C, D. You combine these as well. You have a row. Yes, you combine. So like this one, I made this one. Please check. So now I would like to find the support for A. So the support for A is what? 1, 2, 3, 4 divided by the total number of transactions. So this one, am I right? This is almost what? 80%. Am I right? 80, you'd say. What is the support for BD? Oh, I see 1 divided by 5. The support for BD. What is the support? I see. Okay, good. So this means what? 100%. Think of these as like you have from 0 to 1, like probabilities, because we are dealing with likelihood. These concepts are brought from probability, but they are changed or customized. So people, we would like to adapt it into this context of this problem. Okay, good. So it is 1. Why? Because you have BD 1, 2, 3, 4, 5, and you have 5 divided by 5, which is what? 1. Compute the support for item set ABD. Is this one true or false? Please check this one. It might be, yeah, so you have to make sure. What is the support for this one? Is this one correct? We will check. ABD 1, 2, we add 3, 4. Yes, good. Always we have to check. Now we go next. So we would like to compute the confidence for the previous rules. So what is the confidence for this rule? We have to go back looking into ABD. So It is the support of ABD divided by what? Support of what? BD. I hear. What is the answer? What do you think? Okay. So what is the confidence for this rule? It is what? The support of the order doesn't matter because it is a set. You know my point? B, D, A, B, D for the support. It is the same. You got my point? Divided by what? Support of what? BD. So I see some answers agree. We will go. You checking? Is this one true? We are doing this one, not that. You see my point? Hopefully you didn't get confused. You see? Yeah, we are computing with this one. So with customers. So for ABD, please check if this one is true. We count now. 1, 2, 3, 4 divided by 5. Yes, this one is fine. BD 1, 2, 3, 4, 5. So this one is right. Am I right? This one is 80%. 80% of these customers who bought BD also bought what? A. So confidence is what? 80%. Is it clear? 80 of those customers who bought BD also bought what? Association, co-occurrence. Like 80 of these also bought these. I'm associating. You see the point? That's it. So 80% A occurs here. Am I right? So this one is, look, we would like to see what here. Let me erase this. Okay, so where is BD? BD, 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 BD. Look at A. 1, 2, 3, 4. 4 divided by what? 5. This is another visualization. You see my point? So first I find these. I find how many containing the right hand side here. Okay? So you have two ways. As you like, you could do the computation. If this number is 1, meaning what? Every, in terms of this one. Hopefully the meaning of the confidence is clear. Is it clear? Yes, I would like you to think about it always. Because this is important. Like if you have a problem in real life, you could do it. You would like to find the association. You might need it in any problem. We have many problems in life. Biology, medicine, like computer science, like social networks, whatever. You see my point? So you might have like some information you would like to find the association. Then you do another step analysis. You know my point? So uh, solving a problem is a complex. So you do some problem formulation. You might use this one in indirect way. Okay. So what is the confidence for this? A implying BD. It is just the support of these combined. The support here is like here. Am I right? It doesn't change. Although I have different rules. You see my point? So keep it in mind as an observation. Clear? Good. Now, because I'm computing the confidence, this is on the denominator. For this rule, this will be here. The denominator will be what? BD. The denominator will be what? Numerator is always the same. If you have the same elements, when you combine both left and right hand side, you have the same support. But denominator is different. It will be the left hand side. So this says everyone who bought A also bought what? BD. So confidence, this is the meaning of 100%. Okay, so suppose you are giving this task. Look, this is the task. Given a set of transactions, find all rules, implications, I mean, having both. Look at this one. Support greater than or equal to minimum support threshold confidence greater than or equal to minimum confidence threshold. You would like to have high. You see my point? So you would like to make sure that people will buy like this and you have a confidence for the items in terms of their association. Brute force is what? List all possible association rules, compute support and confidence for each rule, prune rules that fail, like you exclude these that fail in terms of what? Minimum support and minimum confidence threshold. This problem is computationally prohibitive. We will talk about. Okay, so if you have the unique items A, B, C, D, you know my point. So the total number of item sets is what? 2 raised by what? D. Because you have item in the set or not. So you have two possibilities to be included. If you have D of them, so you have 2 raised by D. Okay? I know an item could be in the set or it might not be in the set. So I have two choices or two possibilities. If I have D items, 2 raised by D. If you have constraints saying you have to have, like in the association rule, we have to have at least an element on the left and the right hand side. Am I right? So how many rules do we have? 2 raised by D minus 2. We cannot have empty sets on the left and the right. For association rule, this should be an element, at least an item here, at least an item here. It cannot be empty. Okay? So, okay. Now I'm going back to what? How many association rules? The total number of possible association rules is what? 3 raised by D minus 2 raised by D plus 1 plus 1. Here is an example. We plug this one. How many different items do we have here? Please check. 1, 2, 3, 4, 5, 6. Do we have something else? That's good. So how many association rules do we have? Plug the number. 3 raised to 6 minus 2 raised to 7 plus 1. You get this number. We have 602 rules. It is very exhaustive. You see my point? So I have many rules. Now, look at this one for support and confidence. Do agree that if we combine items on both sides for each rule, we get the same support? Do you agree? Because the support doesn't care about the order, left or right. It just combines, calculating. That's it. Am I right? Okay. So support here is what? The same. We are talking about not a specific item set. Once I say support here, we are evaluating the support on the association rule, like before. Okay? So the support for each association rule is the same. Agree? Now, look at the confidence. It changes. Now for you, if you have something, you are working like as a computer scientist or AI researcher, you do the following. Which one you are going to give, like to inform as an important rule for like you think this is like the most important? I would like to tell so people will like use it in their own business. Which one is the, if you would like to rank rules, which one is the most important now? Yes, good. This one. You are saying everyone who, if we are talking about, let us talk about transactions here. Okay. Every transaction containing beer and milk also contains what? Diaper. Yes, good. What about this one? Every transaction, sorry, 50% of transaction of milk also contains what? Diaper and beer. This one is like, you could say you are not confident. You see my point? Diaper and beer might not be strongly associated with what? Milk. You see my point? So the next, the next important is what? Or important ones, these. So you say like 67% of those transactions containing milk and diaper also contain what? Beer. So you could say, okay, you could do something with it. Also for this one, you could be smart as well. You could decrease the price of this one, you increase the price a little bit. You know my point? So I think you have seen this one without feeling, or you might notice, oh, this one is a discount. They know that you are going to purchase something with it. So they might increase the price, the price up for that one. Okay? Yeah, it depends. It is a business like, yeah, it is like a business. So for all the above rules here, we have binary partitions. Am I right? Binary. So of the same item set. Okay. Left, right, binary. That's it. Nothing like. So rules originating from the same item set have identical support. We agree. Am I right? Here. But can have different what? Confidence. Okay. Thus, we may decouple support and confidence requirements. Okay. So there are, this is like the two-step approach. If you would like to find frequent item set, you generate all item sets whose support is greater than minimum support threshold, and you have rule generation. Okay. So we have frequent item sets. We would like to generate all item sets. For frequent, meaning what? Each item set is greater than or equal to minimum support threshold. You specify this one. This is called what? Frequent item set. Rule generation. You generate according if it is greater than or equal to minimum confidence threshold. Okay, so frequent item set generation is computationally expensive. Why? We will talk. So now we are talking about, before that one, we talk about what? Rule generation. Let me go back to remind you. Or we are here. So suppose you are given a frequent item set L. Suppose this one is given to you. How many candidate association rules? We could have this one. Do we agree? 2 raised by k minus 2. Because left for this case is ignored. Am I right? You cannot have empty. And left and empty on right. You cannot. So at least one in each side. Because you would like to associate, to give like useful information. Now let me go here. Now where are we now? So we would like to find all association rule or rules satisfying minimum support and minimum confidence requirements. Okay, I will erase this one. Once I will update the slides. This is like repeating. Okay. Now we use an algorithm called what? A priori to generate all frequent item sets. Okay. Here is the principle for what? A priori. Think of this one. Any subset of a frequent item set must be a frequent. Do you agree? Like if you have A, then AB. AB, this item set, is a frequent item set. You know already that what? Any subset like A, B would be what? Or AB itself would be what? A frequent. We agree? But any superset, suppose you have a non-frequent item set like AB is like less than 0.2. If you add more item, this becomes superset. This must be not a non-frequent item set. Do you agree? I will update this one. It is like typo. You got the point? Let me know. So if you have like this one, I know this item set is frequent. Any subset would be what? Frequent. If I have an unfrequent item set, in other words, it doesn't satisfy the minimum threshold for support, for example. So if you add more, for sure this will be not a frequent item set. Is it clear? We will go through an example. So I would like to, for the a priori algorithm, we use what? What does it mean for left? Okay, so I will talk about the algorithm, a priori algorithm. Okay, so I know that time is like moving. Also, next class we will start from a priori algorithm. So to generate, and then we will show you how to, like, once we find frequent item sets. So then we generate like association rules. So yeah, for now, for this moment, I know that. Try to revise. I will update the slides for this part only, like this one, non-frequent item set. Yes. So I just try to get familiar. So next time I will talk about these, like how to generate, how to find like frequent item sets, and so on. Let me know now if you have any question so far. So keep in mind this one. Yes, this one. I would like to find frequent item set to generate them, and I would like for rule generation to satisfy as well. This one, frequent item set, meaning what? An item set that satisfies this threshold, which is in terms of the support. So support is greater than or equal to minimum support threshold. It is a user defined. Okay, so inshallah we will talk about this one, and let me know. So we will try to use like some R packages to find these, like for a priori, and these we will do with it. No worries. But just now, for this moment, I would like to show you how to do the calculations. So you see, so in the future, if you would like to do something, you are interested, you could do it. Just you have to have an idea. That's it. موفقين؟ ولو في سؤال على البلاك بورد